So again, page 1 in your book looks just like the handout you have. So you basically have 3 of the same pictures. The handout's double-sided. Okay? So we're entering a unit where we're going to be talking about modeling certain functions. Okay? We're going to talk about linear functions. We're going to talk about quadratic functions. We're going to talk about exponential functions. All right? And so we're actually going to be discussing this for a couple weeks. You won't have another test in here for a couple weeks. It'll be a little bit of time. All right? By the way, anything that we're doing right now is headed towards the second 6 weeks. So the first 6 weeks is done unless you turn something in or retest or whatever. Okay? And so the way that we will test when we're using some College Board activities is like at the end of a section here, we'll have 2 tests. We'll have a free response question, so an FRQ part where you'll be writing out the answers, and then we'll have a multiple choice part, all right? So each of those will count as a test grade, all right? So your FRQs will count as a test grade, your multiple choice will count as a test grade. So just kind of give you that update right now, but we'll get there later in the 6 weeks, okay? For right now, we're going to kind of talk about some definitions, characteristics, examples, and non-examples of these 3 functions. So we're going to start with the easiest one, I think, all right? And we're going to discuss linear functions. So I don't care which one you use. You can use the book first. You can use the page first. I don't care. All right? We're going to look at all 3 of them. So here's what I'm going to do. I'm going to give you 2 minutes of quiet time. All right? So you're working by yourself. I want you to tell me what you know, put on your page what you know about linear functions. You can give me an example. You can tell me a definition. You could give me characteristics. But write down what you know about linear functions on your page. All right, so what I'd like for you to do now is you can turn with your partner, turn with somebody in your group right there or whatever, and share what you got. Let them share what they got. See if you can fill in a little bit more about this. Put some other things that you know about it on there. All right?
Turn around.
I don't understand. Help me.
Oh yeah, I have one. And the week before that.
I had to take time to recover.
All right, here we go. Let's come together now. All right. So share with me, all right, as you were sharing in your groups or whatever, share with me some of the characteristics, share with me some of the things that you know when we talk linear function. All right, linear function is just a linear graph, linear line. We're talking about those things there. So somebody share with me what you got. Did anybody define it? Okay, what you got?
A straight line.
A straight line, okay? So we could have characteristics would be a straight line.
Will it be the slope?
Okay? You could say slope. That's good. So slope is a good one. All right. What's the official name that we give slope? Constant.
Rate of change.
Rate of change. So slope is constant
Rebound right there.
rate of change. All right. So that's how we refer to slope. All right. Somebody said y equals mx plus b. All right. I could say y1 minus y1 equals m and x minus x1. We talked about that a little bit earlier in the year. What is that?
Point slope form.
That is point slope form. Nice. Sometimes College Board likes to write point slope form this way. Is that the same thing?
Yes.
What did I do?
Just add
I moved this y1 to the other side with addition. So I added it to the other side so we could write it that way. It's the same thing. Okay? Anybody else? Okay. Okay. I think you're talking about the equation. I think you're thinking y1 minus y2 over x1 minus x2. That's definitely a part of it. That's how I would find my slope. Okay? Is that what you're referring to? Okay? There is one straight line that is not a linear function. X equals any number. A vertical line is not a function. All right? And so these are non-vertical lines is what we're talking about. So a characteristic is it cannot be vertical. All right? So non-vertical is what we want. We don't want a vertical line. Okay. No, that's in characteristics too. Okay? All right. Now, examples. We could say y equals 2x minus 1. That would be an example of a linear function. We could say f of x equals 4x plus 2. That would be an example. Okay? Matter of fact, I could put parentheses around that, do that. Is that still a linear function?
Yes.
Yes. Okay? What does a graph of it look like? Well, you told me it was a straight line. It just can't be a vertical line. So any slanted line, any horizontal line, any of those work. All right? Now, we're talking right here, multiple representations. We're talking about an equation. We're talking about a graph. How else could I show a linear function? Could I show it with the table? Okay. So 1, 2, 3, 4. We'll go 3, 5, 7, 9. This is a linear function right there in the table. Can you prove it? Why? It's got a constant rate of change. The slope. That's correct. So these are going up 1. So plus 1, plus 1, plus 1. These are going up 2. So plus 2, plus 2, plus 2. It is a constant rate of change. Okay? So that leads us kind of to the definition. So definition here is a relationship between two quantities with a constant rate of change. Keyword being constant. So a linear function is a relationship between two quantities with a constant rate of change. Now, let's go to some non-examples, all right? What would not be a linear function?
A vertical line equals
Say again?
equals.
Okay, x equals like 1, or whatever that would be, a vertical line. Okay, good. Somebody else said something up here in the front.
I said vertical line.
A vertical line. Okay, y equals x squared. If it had an x squared in it, we wouldn't want it, because that's something else, right? We'll talk about that more in a minute.
A chart without a constant rate of change.
Okay, you could have a chart that didn't have a constant rate of change. Good.
You can
All
have
right.
a graph with the round.
Okay, if you have any type of curved line, okay? So if you have a graph that was curved, all right? So if you have a curved line, it could be this graph, it could be a parabola, it could be anything that's curved, okay? So any curved line we don't want. How about this right here? What if I gave you this equation?
Where is it?
Is it this one right here? Is that linear?
No.
What is this one? Thank you, x exponential, all right? It's exponential. So if it was 2 times x, that would be a linear function. If it was 2x. If it's 2 to the x, if it's an exponent, then it's an exponential function. Okay? Everybody all right there?
Yes, sir.
All right. So find a different sheet now. Either use the paper or the book, or we'll find another page. All right? So we're going to do this again. Now you kind of got that hang of what I'm asking for. All right? And so the next one, we're going to talk quadratic function. So again, I'm going to give you about 2 minutes. I want you to write down what you know before you use your neighbor. Write down what you know about a quadratic function. You could define it. You could give me characteristics. You could draw me a picture. All right? That's what you do.
So, what about a graph? Where was I?
I just put like a
Let me up.
All right, so we've already started this process, so go and share with your neighbor what you know. See if you can fill in a little bit more.
I don't know where it is.
No, that is so crazy. Bro, that was like, we don't need to tell a story to everybody now. That was like 5 minutes ago. That thing does not have
This dude that I like to eat dog.
Can I have it?
I used to think you were eating.
Why are you putting on hands and I thought about
I really will do something. All right. obviously you just need me to talk the whole time and lead the discussion. All right? I don't think I want to do that the whole time. I want you to have some good, intelligent conversations with each other. But I need you to be on task. All right? So, did anybody come up with a definition? Is this one a little bit harder to define?
Yes.
Actually, I think this is the hardest of the three that we're going to talk about today. This is the hardest to define. I'm going to build some things before we get that here in a second. We probably started here with characteristics. That's probably where I'd start. What characteristics did you discuss or that you came up with? Okay, it has a vertex. All right? So a quadratic function has a vertex, which a lot of times could be the minimum on the graph, or it could be the maximum on the graph. So that's important. Okay? Somebody else, anything else that you know about a quadratic function? Domain is all real numbers. What do we call the graph? What do we call the graph of a quadratic? We normally use the word parabola for that. Okay? And so, have this here, and we'd have a graph. So there would be a good example of it. What else? It is curved. Okay? It's not a straight line. Let's talk about the equations. What's the key thing in the equation that indicates to me that it's quadratic? It's got the exponent. It's x squared is what we have. So anytime you see x squared, we know if that's the highest one that we see, we know that is quadratic. It's parabola. Okay? Now, we discussed this one already because we did a little bit of solving with these a week or two ago. But there are a couple other ones. When we did this, how did we solve that? How did we solve a quadratic? The rainbow thing. That is factoring. Okay? So we factored. And so we can write this in this form right there. That would be one of the forms that we could write it in. We refer to that as root form or factored form. So this is root form or factor form. Okay. So those are the two ways that we've kind of looked at it here recently. Now, give you another one. We'll be investigating more of these as we go, so we'll talk more about this. This is a third way that we can write this equation. Okay? Some of you probably have seen this before. This is transformation form, or this is also called vertex form, because it gives me the vertex. X minus h. Okay, x minus h plus k. The red one, R. That's root 1 and root 2. Okay. All right. So there's the way that we could write it. Now, I can add a little bit more here. If I add a couple examples, there could be an example. That's a pretty easy one to do. All right. I could write it in a couple different ways, but that would be an easy one. All right. You probably could think of some non-examples pretty easy, because what would you list as a non-example? Straight line, for sure, yeah. So if I said like y equals 2x minus 8, straight line, would it work? Obviously, if we had like an x cubed in it, that wouldn't work, because I'm just talking about x squareds. The 2 to the x that we talked about a while ago, this is not exponential, so have that there. All right. Now, the last thing I want to do here to help me to kind of build a definition of this one is I'm going to look at a table. So in the examples, I'm going to build a table. So I'm going to say I've got 1, 2, 3, 4, and I have 0, 1, 4, 9. All right. So there's the table. Now, some of you are having a little small conversation on the side, and you're going to miss this, and this is a really important thing. All right? Is this a constant rate of change in this problem?
No.
No. But I'm going to write it out. I'm going to write out what I see. To get from there to there, that's plus 1. To get from here to here, that is plus 2. Or plus 3, excuse me. Plus 5. Plus 7. Okay? So we see that's not a constant rate of change. So we know it's not linear. However, I want to compare the next little piece. Compare what I just wrote down. That's a difference of 2. That's a difference of 2. That's a difference of 2. All right? We refer to this as second differences. The blue is the first differences. If the blue are constant, then it's a linear function. All right? If I do the second differences and they're the same, then that is quadratic. All right? So the other way we talk about this, second differences, or we say that it has a linear rate of change. Okay? It has a linear rate of change. So if I were to go up here and I define this, this is a relationship between two quantities okay? So it's a relationship between two quantities with a linear rate of change. So that's the difference, okay? So with linear functions, it was a constant rate of change. With quadratic functions, it is a linear rate of change. I know that's a little bit confusing, but that's how we would define it. All right? And all that means is that my second differences are the same. Okay? Everybody okay there? Okay, I'll give you just a little bit more time to get that down. Could you come up with more non-examples if you needed them? Yeah. Sure. Sometimes is it easier to define something by what it's not than what it is? Yes. Sure is. Okay? So that's kind of why we do that. All right. The last one. So the third example that we're going to do, we're going to talk about a exponential function. Okay? Exponential function. Anybody need this slide anymore? All right. So I need you again to write down what you know about exponential function. Okay? So write down what you know about exponential function. All right. Share with your neighbor what you found.
Ow! My foot's asleep and you just hit it. I'm waiting for the tingling to go away.
All right, here we go.
Sorry.
Again, when we're doing this, we're having conversations about exponential functions is what we're doing right now, alright? Not having all the other conversations. We're gonna be doing a lot of time where I want you to discuss and I want you to share some things, but I want you to do that in a manner that is an academic manner instead of a social manner, alright? Now, let's discuss exponential functions. You may or may not have come up with a definition. Anybody come up with a definition to start? Probably going to be a relationship between two quantities, and then we're going to define something there. Anybody have an idea? Okay, we will come back to it. So let's talk about some characteristics then right now. So hopefully we can do that. What characteristics do we know about an exponential function or exponential graph or anything like that? Say again? Okay, so an example would be y equals 2 to the power x. Where is the x? Where is the x in an exponential function? It's in the exponent. Okay? Somebody else. What else do we know?
It's like a little graph that's kind of, okay. It curves, like.
All right, it is a graph that curves.
Oh, yeah, it never touches the.
Okay. It doesn't touch the x-axis. Anybody remember what that's called on the x-axis?
Zeros.
The zeros would be if it crossed. Okay, but this doesn't cross. It just gets really close without touching. Anybody remember what that is?
Parallel. Wait.
It has a horizontal asymptote. All right? It has a horizontal asymptote. Okay? We refer to this graph as being asymptotic. All right? So, which means it's following an asymptote somewhere. All right? So, it's got a horizontal asymptote. You may have done some graphs in the past that were exponential, and you fill in the blank after that. You defined them exponential something or exponential something else. What are the words that go with that? The graphs. Exponential growth, that's correct. Or exponential decay. A lot of times we refer to them as exponential growth graphs or exponential decay graphs. Okay? All right? Now, not yet. We will sometime this year. Okay? The general function is y equals a times b to the x. That would be the general function there. A is going to be a value out front. We'll have b. That's going to be our growth rate or our decay rate. All right? And then we'll have x. You can also have a function that looks like this. In place of the b, we might put a 1 plus or minus r. So that r is our growth rate or our decay rate. If it's a plus, then it would be a growth rate. If it's a minus, then it would be a decay rate. So we're kind of defining what it is there a little bit more. All right? Obviously, could you fill in non-examples? Yeah. Sure. All right, I'll let you kind of do that on your own. The other thing that I want to look at on this, and this is kind of where we are gathering our definition, is looking at a table. So if I look at this table right here, okay. So I got 0, 1, 2, 3, 4, and I got 3, 6, 12, 24, and 48. Does that table have a constant rate of change?
No. No, sorry.
It's got, what is constant about it though? I am multiplying by 2 every time. So I'm not adding. If I'm adding, it's a constant rate of change. Okay? Or subtracting. But if I'm multiplying here, it's not a rate. Anybody got an idea what it is? We refer to that as a ratio. All right? Rate is what we're adding or subtracting. Ratio is what we would be multiplying by. So if I were to come up here and I were to define this, it is a relationship between two quantities with a constant ratio of change. All right, keyword being that ratio is what has changed here. Linear is a constant rate of change. Exponential is a constant ratio of change. Okay? Any questions about that? All right, before we leave, put you a few non-examples if you haven't already done so in there. All right? Now, let me share this information with you real quick as we're kind of closing the day. All right? We won't have a assignment packet like we've had. All right? The book is where you'll be getting your daily grades from. All right? So as we work, you're following along in there. And then from time to time, I'll give you a couple problems in that book for homework or whatever as we go. So I will grade that book. So the page that you just picked out, all right, or the page that you picked up, you put in, you need to either put it in your book or you need to put it somewhere that's secure. Don't throw it away, all right? That's worth points for your daily grade. See that, all right? Yes? Excuse me? Not necessarily here. Okay? Now, I know this is very disappointing. We're almost out of time, and you do not have any homework. So I hope you can live without homework for a night.